Hi, I'm Tom Taylor, the owner of Taylor's Nailers. We specialize in making improvements to unique homes such as this one that I'm standing in front of in Pacific Heights. Oftentimes in homes such as this, there's a large open space or open area that's unreinforced. In the event of a seismic activity, there runs the risk of failure or damage. To protect the investment, we are installing a steel moment frame, and in doing so, we've been able to capture extra space to be used for parking and thereby getting multiple benefits for the homeowner. So come on in, let's take a look around and see what's been going on. So soft understories are a very big problem in California because of all the earthquake activity. Earthquake activity can come in two types of waves. There's the lateral wave, which produces racking in your building, racking being the side-to-side movement and can throw your building off the foundation. There's also something called a transverse wave, which is the up and down wave. That too can throw you off, can throw your building off your foundation. So what a moment frame does is it creates a solid structure to resist that side-to-side movement or the up and down movement, and creates a very strong box. In the event of an earthquake, your house is much better able to withstand that seismic activity because of the resulting rigidity. So what we have here is showing our cribbing. This is a support for a metal backbone or beam running down the middle of the building where the load is transferred all the way down. This can take tremendous loads, and it supports it temporarily while work is done on your building. So what we're looking at here is a rebar cage, the rebar being the name used in the industry for reinforcing steel. This is a double reinforced steel cage in preparation for a large moment frame and wall that's going to go across the entire length of the building. If you look down at the bottom, you see gravel, and then you also see another cage. The cage at the bottom is actually called a mat slab foundation. This mat slab foundation is 18 inches thick and it's 6 feet wide. This is designed to help spread the load across unconsolidated, it's called, soils. So we're ready for the pour, and as you can see, there's a lot of structure in here to support everything. These whalers that we are showing on the side of the walls here are going to hold the concrete in place. Concrete weighs 4,000 pounds a yard, which is a lot of weight, let me tell you. If you look over here, come on over here. The new moment frame is going to go in place right here. As you can see over here, we've got large bolts that extend down into the concrete 6 feet, and they give a lot of strength, a lot of lateral load in the event of a seismic activity. You'll see that we've got scaffolding. We're making preparations to vibrate the forms. So vibrate the concrete to make sure there's no void and that the concrete is consolidated when we go to strip the form. So you can see the forms look wet. We've put oil on the forms in order to make sure that these things come apart easily. If you look down here, these are called whalers. These 2x4 structures resist the load of the weight, like 4,000 pounds per cubic yard. And we use this something called a snap tie that snaps them all together and allows us to hold it in place. So concrete is heavy, it's messy, and nobody likes to move it. So we use a pump truck to move it. It pumps it down this 2-inch tube and brings it into the forms as we direct it. It's still heavy, but it makes it a lot easier. So Carl and I will be down below. You guys will probably be up here. Alan, you can use you and him will place the concrete, okay? Okay. And Kelly will consolidate. You'll have the vibrator, okay? putting the first load of concrete in. That's good news. So now just about another 2 or 3 more. Well, we finally finished the pour. There were some nerve-wracking moments, but we got through them, and we're pleased. We got it in 3 truckloads, and now we have to do a cleanup, and that's always the funnest part. All right, welcome back to the pour and the pit. We're back on site after 2 weeks of intense work. We've pulled the concrete forms off, and we've exposed the concrete. As you can see, we've done a lot of work and installed a lot of steel. This incredibly strong steel structure at the heart of this beautiful old building will make it much more resistant to the damage that earthquakes can cause. Okay, as you can see, we've got some shear that's installed. These metal plates that are installed actually serve to spread the load in the event of an earthquake and transfer the load so that the whole building works against this incredibly strong moment frame. You can also see that there are right angle braces to help give it strength in the event of that side-to-side movement. And then also too, if you look up here, you can see that these are called continuity plates. That transfers all the load to the side of the building. Very important and a lot of work to accomplish. So some interesting details. So what we're seeing here is reinforced I-beams. These I-beams are connected on both sides to the concrete foundation walls. The foundation walls serve as a buttress, and in the event of an earthquake, it stiffens it on side-to-side motion. So it makes a very strong structure while having the added benefit of also giving a nice deck for parking and everything. Well, we're at the day of the pour. This is the big day when things come together and we start to have some resolution. As you can see, we've got the moment frame up, the steel's in place, it's all bolted and it's all been concreted in. Now we've laid the deck pan. If you look at the deck pan has been welded down to the steel embedments that we put into it. We're now ready to, we've got steel rebar passing through the concrete, and we've got a floor drain in the middle of the floor to allow any water to slope towards that. These guys have worked with me for a while now. You can see that in the middle they've got a 2x4, that's called the screed rail. That sets the elevation as they drop the concrete down to the drain line there. They've set a perimeter chalk line, and then they very carefully pour up to that chalk line, and they tamp the concrete and make a they make the elevation on the concrete, and then they use that concrete as the screed rail on the other side. So then once they've done, as you can see, they're pulling the screed, that's the 2x4, towards them, and in doing so they level the concrete and they pull it and they backfill with a little bit of concrete if they don't have the right level or there's any holes or anything like that. So you can see them pushing the concrete around with their feet. It's a common technique, that's why everybody wears rubber boots. This is an overview of the work we've done to make this home better able to withstand the inevitable earthquake that affect the San Francisco Bay Area. There's a lot of work and a lot of attention to detail that goes into completing a complicated project like this. So if you're concerned about the strength of your home in an earthquake, please contact me, Tom Taylor of Taylor's Nailers.